Greetings, welcome back to part 2 here. So let's go ahead and finish off this lab. We're going to take a look at the quantitative data and then we'll discuss real quickly the on your own problems that you need to type up. So we're now at the point where we're going to go ahead and take a look at possibly doing some graphical analysis of the data that we've been looking at, the CDC data. But in particular, we're only going to look at the quantitative data, and we're going to look at graphs for the quantitative data. And we'll also show how those graphs are interpreted and show their summary or their numerical descriptions along with them. So let's go back over to our studio. So cleaned up my console a bit, cleaned up everything in here. So you may have taken a break and shut everything down and then come back to this. And if that happened to you, then it's really important to make sure that you're still seeing up over here in your environment the CDC data set. If you're not, then do not pass go, do not collect $200, go get that back into your environment. So I'm going to go in here into my assignment template. I'm going to just grab that source command right off of there, or you can get it off the HTML file. It doesn't matter which place you get it. Go ahead and paste it back down here in the console and go ahead and run that. If you're having trouble, all of a sudden things are not working, could be that you've killed the data or you've put the data away when you close things and things aren't going to go too smoothly for you. Okay, so got the stop sign, so we're bringing the 20,000 data points back in. By Jove, there they are. So let's go back to our regularly scheduled lab here, and we're supposed to start off with looking at box plots. So let's look at a box and whisker plot. And in particular, we're going to look at a box plot of the heights. So CDC and then the height data. Okay, so if we do that, come over here into our plot tab, we'll see the box and whisker plot. If you click on zoom, it'll give you a bigger version of it so you can look at it. Pretty nice little box plot right there. Okay, we're going to come back and talk about that in just a minute, but let's go back into the console and let's do summary of the CDC height. That'll help us out with our discussion of what these crazy plots are all about. Okay, so the minimum, the first quartile, the median, the mean, the third quartile, and the maximum, those numbers, besides the mean, this number is not on there, are all represented on the box and whisker plot. So the minimum is going to be this value down here. The first quartile, that's going to be the first hinge or the lower part of our box. The median is this dark line down the center of our box. The third quartile is the top part of our box. And then the maximum 93, that's up here, that's this point up here, okay? So I can't draw on this image while I'm here in R, so let's go ahead. I've made a copy of this and exported it so I can take it over into my little drawing utility so we can talk about that again, okay? So let's take a look at what these different points are. So this value right here and this value right here, this value right here and this value right here, and as a matter of fact, this value right here are all part of what we call the 5-number summary. Those are the numbers that were just represented in our summary back there. So let's go back over to R for just a second here. So the 48, that's this number down here. That's our minimum, okay? Q1, that's 64, that's this value right here. The median, 67, that's that value right there. Q3, that's 70, that's right here. And then our maximum, which was 93, that's right up here, okay? All right, so that's how actually the box and whisker plot, the basic parts of it are put together. They're on a number line, and we plot based upon those numbers. In other words, those numbers are part and parcel of how we make the plot. Now, there's a couple other things that we can get off of the box and whisker plot that are also really valuable to us. In particular, this distance right here, which is the interquartile range. We remember from our previous discussion, the interquartile range is defined to be Q3 minus Q1. So that would be, in our case, would be the 70 minus the 64, okay? Which we can get R to give us back directly if we'd like, if we're so inclined. We can type in IQR, CDC, the height, and it gives us back 6. And with a little bit of arithmetic ingenuity, we can see that, by Jove, that is correct. That 70 minus 64 is 6, okay? All right, well, we got to do a little bit of more discussion about what's going on in this plot here, because you notice these little dots, and we notice these whiskers, and like, what is going on here? Well, it turns out that one of the things that a box and whisker plot does is it sets up a couple of delimiters for us. And what those delimiters are doing is they're setting apart what we would expect to see and what we suspect are unusual or different than the rest of the data points. So all of these points here, all of these guys that have the dots here and all of these guys that have the dots here, those are what we call suspected outliers. So we suspect those points to be different than each other, so we will call those suspected outliers. Now, how do we go about doing the calculation? How do we find those? Or what do we use for this metric here? Well, it turns out that this distance, we take the interquartile range and we add 1.5 times that interquartile range to Q3. So in other words, this distance right here is Q3 plus, or the position, I should say, not the distance. The actual distance is 1.5 times the interquartile range. So 1.5 times the IQR gives me the distance from here to here. That's what that distance is. But to find this, that's what I meant to put the arrow at, to find the actual point for the hinge here, I take Q3 plus 1.5 times the interquartile range. So that 1.5 times interquartile range, that's you kind of can think about that as like my measuring stick. That's this distance right here that I use to decide, okay, if you were that distance above Q3, we're going to consider you an outlier. And then synonymously, the same thing down here. Again, this distance is 1.5 times the interquartile range, again, right there. But to find the point to the hinge, or to the whisker right there, we're going to say, okay, that is Q1 minus 1.5 times the interquartile range. Okay, now fortunately for us, we are in the era of life where most of us do not have to do these calculations by hand, unlike I had to when I took this course, but still it's important to know how it's actually doing that. Okay, so back to the regular scheduled program. Let's go back over here to R, and let's go continue on with the lab. So one of the things that is important is to be able to perhaps do a comparison of box plots. That a side-by-side comparison of box plots turns out to be a very valuable thing that we want to do. So we're going to compare the heights of men and women to each other. And so what we'll do is we'll create what's referred to as a model. And basically, to think about a model is very much to think about like we did back when we were doing function notation. So the command that we're going to be inputting is the box plot command again, but this time we're going to be doing, let me go ahead and bring it over here so we can talk about it. We're going to take CDC height and we're going to model the height based upon gender. And so what that tells R to do, it says, take a look at the height, and what I want you to do now is I want you to create a box plot for each of the genders. So in this case, we only did 2, so that means male and female. So let's go ahead and run that and watch what that does. And notice it creates 2 box and whisker plots this time. Let's go ahead and zoom on that. We get 1 box and whisker plot for the males, and we get 1 box and whisker plot for the females. So we can take those heights and we can compare them to each other, and we can make some statements about what we think about the heights of males versus females, and hopefully this fits our intuition. We see that on average that males are taller than females. So the box and whisker plot for females is shifted a little bit lower than it is for males. A couple other important things that we can see here. It appears that the interquartile ranges are roughly about the same. In other words, the variability in heights appears to be about the same for men and women. As when we look at the whiskers, we see the same thing too, that there's not a huge amount of difference in the variability. Although, looking at the outliers, we see that there is an extreme outlier. We have a really tall guy at 93 inches. That guy's a giant, right? We got, Kareem Abdul-Jabbar here or something got into our survey. Okay, so really a valuable thing is to be able to do side-by-side comparative box plots. The trick is that you take the variable that you want to make the box plots on, and you put the tilde, the model command. That's a tilde is a shift function above your tab. It's right up there in the upper left-hand corner of your keyboard. That says model it upon whatever the other variable is that you're looking for. Okay. All right. So let's move on. I'll let you chew on that one for a bit. We're going to come back to that tilde several times during the semester. Okay, so the next thing that we want to do is we want to do a calculation. We want to create a new list, and the new list is going to be based upon what's called the BMI, or the body mass index. There's a link in the lab if you want to learn some more about that, to the Wikipedia statement about body mass index. But basically what it is, it's a height-weight ratio, and then it's multiplied by a fudge factor of 703. That's a conversion factor to change units from metric meters and kilograms to imperial inches and pounds. Okay, so the BMI is in meters and kilograms, and so we do the 703 so everybody's on the same book. Okay, so they give us a couple of commands to help us out here. So we're going to create this list of the BMIs, and the way we're going to create this list, or this vector of the BMIs, let me just go ahead and cut and paste this in here for you, is we're going to take the weights of everybody and we're going to divide that by the heights of everybody squared, and then multiply that by 730. So the arithmetic here, just to let you know, that division is of course the backslash, the caret gives us the exponent, and the star gives us multiplication. And again, you can use the left assign, no problem, or you can use the equals if you decided to type this in on your own, and it'll do the same thing. Whatever, we just noticed now that we've got a new vector, 20,000 elements in it, that is referred to as BMI. Okay, so now what do we want to do? Well, we want to do a box and whisker plot of the, whoops, sorry, my bad, wrong. Let's undo that. That's not what I wanted to do. I don't want to do that again. I want to do a box and whisker plot of the BMI, the body mass index, based upon what the general health was. Okay, so again, before we hit return, let's see what happens. Let's think about this. So what are we doing? We're taking the body mass index and we're going to create a separate box and whisker plot for the body mass index for everybody based upon their general health, or what they reported for their general health. So we're going to get a lot of box and whisker plots this time. So notice it gets really cramped over here. So let's click on zoom, and then we can see a much better version of that plot. And notice that we have a box and whisker plot for each of the different reportings of their general health. Okay, so we have excellent, very good, good, fair, and poor. But again, the vertical axis is body mass index. So just to make our lives a little better here, I'm going to go ahead and put a Y-lab here to kind of make that maybe make more sense for us, and just put BMI on that vertical axis for us. Okay. All right, so now if I go ahead and zoom and take a look at that, notice that this is BMI. So again, we modeled the body mass index based upon the reported health status. And what we see is that there are a lot of outliers in terms of the body mass index. There's a lot of controversy about how useful the body mass index is for a measurement of overall health. But that said, what we do see is a trend in the box and whisker plots, in that folks that report themselves in being better health tend to have a lower BMI. Okay, in other words, their BMI, or their body mass index, tends to be smaller if they are in better health. There's kind of an upward trend here, and a much increase in variability in the interquartile range as we start getting up towards the poorer health. Okay, so that is why many times one of the predictors that many folks use for health is the body mass index, is that if your BMI is low, you're probably in better health. Okay, all right, whether that's true or not is always, to be talked about. Okay, so I'll let you finish reading up the rest about what it actually did there, but let's go and move down to the next type of graph that they want us to do. Oh, sorry, excuse me, we haven't finished with these yet. They have a few they want us to do in exercise 4. Okay, so what does the box plot show? Pick another categorical variable from the data set and see how it relates to the BMI. List the variable you choose, and why you might think you have a relationship with BMI indicate in there. Okay, so let's go back up and take a look at CDC. So you can pick any categorical variable to help us, again, break up the BMI, which is a quantitative variable. Keep that in mind. And we're just breaking it up by categories. So how about exercise any? So we can come up here and we can change this CDC to X or any. Okay, and go ahead and do a side-by-side comparative box plot here. And let's see if there's any relationship to that. Okay, so 0 says we didn't exercise, 1 says we did. It's looking like what? That we have a higher body mass index for those folks who don't exercise versus those folks who do exercise. Oh, surprise, surprise, right? Yeah, I could have figured that one out without having to look at this. Okay, so let's just do one more just to make sure we got the idea of this. Let's go ahead and do a box and whisker plot, and let's take a look at the body mass index based upon age. So let's go ahead and change the categorical variable to, excuse me, not age, because age is not, I meant to say, oh my God, health plan. I'm sorry, health plan. That's what I was going to say. Sorry about that. I was having a little bit of a brain fart there. So let's go ahead and take a look and see if they happen to have a health plan, okay? So is there any relationship between the body mass index and whether or not you have a health plan? It doesn't appear to be, okay? So the folks who don't have a health plan versus the folks that do have a health plan, appears that the body mass indexes are relatively the same to each other. So in this case, we would say, you know, having a health plan probably doesn't really affect your body mass index. Okay, enough of that. Let's move on to the next type of plot that we're going to use very commonly for describing quantitative variable of a single variable. It's called the histogram. And so the first thing that they ask us to do is to take a look at a histogram of the age. So let's take a look at hist, CDC, and let's do the age data, okay? And let's go ahead and again, let's zoom that in a little bit so we can see it. Now this is a really interesting graph, and we talked a little bit about this when we looked at the summary data earlier, and that we suspected that the graph of the age data would be skewed to the right. And looking at the shape of the histogram now, we see that it's unimodal and skewed to the right. Not uncommon that you have, as people get older, there are less of them in the population, and so the right tail tends to drop off kind of long and stretched out, so that we have a right skew or a skewed to the right distribution. So that's really valuable. While we're looking at this, let's just go ahead and counter this with one that would not be skewed. And we saw that the height, if we take a look at the height here and we zoom that, we see that we've got much more of a unimodal distribution. It's not broken up too fine, but we have a much finer breakup in the height than we did before. Now we can adjust the number of breaks that the graph puts in here. We'll take a look at BMI as our example to do that. So if I go in and I do a hist of just straight up BMI, and we take a look at the BMI, again, we'll go ahead and zoom on that. It's not got very many bars, okay? I'm suspecting, it looks like, again, this is going to be a skewed to the right distribution, but I'm having a hard time seeing that with the way that R has decided to do this. So we can go in and force R to change its evil ways here. In other words, we can ask R, say, hey, can you give me more bars? And we can put in the breaks command. So we'll put in breaks equals 50. And we put in breaks equals 50. Notice now we have lots more bars. In other words, it's broken it up in such a way that we can see lots and lots of refinement into it, okay? So let's try that again with the heights command, okay? So let's go and take a look at heights and see if we just put in CDC heights with 50, how that's going to work, okay? So CDC, and then the heights. By Jove, we got lots more bars in there also, okay? So that's something to keep in mind. The breaks equals 50s is kind of a nice generic one, but the thing to see here is, compared to the age and the BMI, is it looks like the heights are bell-shaped unimodal. We have a very unimodal bell-shaped distribution going on for heights. Histogram's a really valuable plot for talking about the shape of the distribution of our graph. Okay, so we're on to the on your owns. Okay, so you need to make a scatter plot of the weight versus BMI, and then you need to do numerical summaries and side-by-side comparative box plots if men tend to view their weight different than women. So I'm going to give you some hints on those, but I'm not going to give you everything, okay? So on the first one, let's come back over into our assignment now because we're going to need to be doing the work over there. First of all, make sure that you've got, before you start trying to do this, make sure you've executed these 2 lines of code. Actually, I repeated myself here. I just noticed that. I got BMI in here twice, but we need to make sure that the source file and the BMI are in your R code, or you're not going to get what you're looking for. Okay, so I've given you a spot here to put in the scatter plot. So I'll give you a bit of a hint. So you, inside of that R chunk, let's go ahead and shrink our console now so you can see, because we're going to talk about our RMD file now. You're going to put in there the plot command. You put in plot, and now you got to put in the 2 variables that you're looking for. So they want you to plot what? Weight versus BMI. So would I just type in weight? No, I can't put that in, right? What do I got to put in? I got to put in CDC weight, right, by BMI, okay? All right. And then I ask you if you could just do a little favor to me. Go ahead and put in an X lab. I'll let you fill in the quotes. Go ahead and put in a Y lab. Again, I'll let you fill in the quotes. And then put in a main, which is a title for it, okay? So do me a favor and get in the habit of start labeling your axes and giving a title to all of your graphs, okay? So that's hopefully a big hint on what you're going to do on that one. Okay, so in the second one it says use numerical summaries and side-by-side box plots determine if men tend to view their weight differently than women do. Okay, you'll need to insert an R chunk here. So let me remind you how to do that. Come up here to insert an R chunk, and now you've got an R chunk going, okay? All right, so I'm going to let you think about that one on your own. That's the challenge question, is this one, number 2. And I'm not going to give you too much more than that. If you are having trouble with it, though, do not be shy about posting questions to the question and answer form, or you think you've got the code but you're not sure, go ahead and post that to the question and answer form. Or you know you got the code but you feel really good about helping other people, go ahead and answer other people's questions, and I will give you a point extra credit if you did that right, okay? Okay, well, hopefully you found this somewhat entertaining, if not informative, and I will see you all back here soon.